Hello students, in today's lecture we will discuss about the properties of gravitational force. In the previous video we have studied about the gravitational law that is given by Newton, and that law is named as universal law of gravitation. In this class we will discuss about some important properties of gravitational force. I write here gravitational force by the symbol F and G. This G represents that this force is gravitational force. The very first property of gravitational force is that gravitational force is attractive in nature. That means if gravitational force exists between two bodies, the two bodies must attract each other. There is no repulsion between two bodies. As like we have studied about electric charge, two similar charges repels each other, but two opposite charges attract each other. As we also studied about magnetic force, that similar poles repel each other, whereas opposite poles of a magnet attract each other. Such case is not happen in case of gravitational force. Gravitational force is always attractive, means there exists attraction only between two bodies if they have masses. The second property of gravitational force is that gravitational force depends upon masses of two bodies. As in the formula also, we have derived the relation that F is equals to G m1 m2 by r square. This gravitational force depends upon the product of masses of two bodies. If we change the mass of any of the one body m1 or m2, the gravitational force will change. For example, suppose if I write m1 is equals to 2 kg and m2 is also 2 kg, then what will be the force? Fg will be proportional to 2 multiplied to, it is 4. Now I am going to change the values. If m1 becomes twice, that is 4 kg, and m2 remains same, that is 2 kg, then now what will be the force? Now the force is 4 multiplied 2, yani 8. If I change the mass of second body also simultaneously, that m1 is 4 and m2 is 3 kg, then what will be the force? Now this time the force is 4 multiplied 3. These examples prove that if we change the value of any of the one mass of a body, then the force will change out. This simply indicates that Fg depends upon masses of bodies. What happens if the mass of one of the body is 0? If I write m1 is 0 kg and m2 is 4 kg, what will be the force? The force will be 0 multiplied 4, and we know that anything multiplied by 0, the result comes out to be 0. That means if a body doesn't have any mass, it will not exert any kind of gravitational force. For gravitational forces, masses of a body is must. A body must have a mass.